Now, when the ventilators are within a short distance from the edge of the reservoir, I mean generally looking at 2 metres, in this case, the movement of smoky gases beneath the exhaust point may be different to the movement beneath exhaust points further from the edge of the reservoir, and you have to use a different model in determining the plug holing. Yeah, in determining the critical exhaust rate for plug holing, there's a different model. So this is the formula to apply, where mcrit is the maximum amount of smoke that can enter a ventilator without plug holing occurring in kilograms a second. G is your acceleration due to gravity, which is 9.81 metres a second squared. D is your smoke layer depth. TO is your ambient temperature of your air. Theta is your increase in temperature of the smoke layer in Kelvin. And TL is your temperature of your smoke layer. Let's do an example using this plug holing method. And don't forget, this should only be applied when the ventilator is less than 2 metres from the edge of a reservoir. Determine whether or not plug holing is likely to occur with a vent located within 2 metres from the edge of a reservoir with the following parameters. Your density of ambient air is given as 1.177 kilograms per metre cubed. Acceleration due to gravity is 9.81. Your ambient air temperature is 293 degrees Kelvin. Your theta value is 50 degrees Kelvin. Your smoke layer depth is 3.5 metres. The temperature of the smoke layer is 343 degrees Kelvin. The smoke leaving each ventilator has been worked out 11 kilograms a second. Putting all known variables into that formula, you should have got an mcrit of 32.93 kilograms a second. So in this case, the smoke leaving each ventilator is 11 kilograms a second, and the mcrit is 32.93 kilograms a second, which means in this case, it is unlikely that plug holing will occur. Let's do another example. Determine whether or not plug holing is likely to occur with a vent located within 2 metres from the edge of a reservoir with the following parameters. Your density of ambient air has been given as 1.177 kilograms per metre cubed. Acceleration due to gravity is 9.81 metres a second squared. The ambient air temperature is 293 degrees Kelvin. Your theta value is 100 degrees Kelvin. Smoke layer depth 2.5 metres. Your temperature of your smoke layer is 393 degrees Kelvin. And the smoke leaving each ventilator is 15.5 kilograms a second. This is a formula you should have put them into, your mcrit. When you put them into this formula, you should have got an mcrit of 17.52 kilograms a second. So in this case, the smoke leaving each ventilator is 15.5 kilograms a second, and the mcrit is 17.52 kilograms a second, which means in this case, it's unlikely that plug holing will occur. Now that covers the examples. Now we want you to carry out some exercises yourself using this formula and getting used to using it and practicing to make sure you check your understanding. Once you've completed them, click on the link below to view model answers.